this is Pat Cosgrove for Cosgrove's Cosmos. Today's video is a follow-up to my previous video where I talked about the hardware selections on the track system for my observatory project. Since that video, I've done some follow-up research on galvanic corrosion, and because of that, I've updated some of my hardware selection. In today's video, we'll talk about what galvanic corrosion is and the changes that I've made to my selections. Let's get started. In my previous video, I talked about some of the hardware selections that I made for the tracking system for my roll-off roof observatory. Specifically, I talked about the wheels and the track system, both for the flat track and for the V-groove track. When I made those selections, I chose iron for the wheels, mostly for their strength, and I chose aluminum for the tracks. There are two reasons that I really chose aluminum. One was the aluminum was a little bit less expensive, and the second is since the tracks will be exposed to the environment out on the outrigger, I wanted something that would be corrosion resistant. With these selections, I now have a system where I have two different metals that are going to be in contact, the iron in the wheels and the aluminum in the track. In doing this, I was aware of the fact that when two metals come in contact, there's a strange form of corrosion that can occur that's called galvanic corrosion. But what is galvanic corrosion? Galvanic corrosion is also known as bimetallic corrosion, and it's also known as dissimilar metal corrosion. Galvanic corrosion is an electrochemical process in which one metal corrodes when it is in electrical contact with another in the presence of an electrolyte. This process is the exact process used in almost every battery that we use to power our portable devices. This phenomenon was named after an Italian physician by the name of Luigi Galvani, who lived in 1737 to 1798. For this process to take place, you need two different metals with different galvanic potentials to come in contact, and you have to have them bathed in an electrolyte, which can often be moisture or water. While seawater, with its dissolved salts, is an ideal electrolyte, often all you need is just moisture to enable this reaction. In the case of aluminum and steel, aluminum is more anodic or less noble than steel in the galvanic series, which means it's more likely to corrode when it's in contact with steel or iron. Other metals in combination can also cause this issue, and I'll show you a chart of the various metals that can play a role in this little drama. I'll have a link to this chart under the fold for those who are interested in looking at what the other metals are. While I knew this was a possibility, in my initial assessment, I didn't think this form of corrosion would be much of a factor. My tracks or rails are about 40 foot long. The roof itself is 20 foot long. But when the two are in contact, we really only have 5 points of contact, which is each of the wheels on each side of the roof. As you're rolling back and forth, the contact is very momentary. So what you need to be concerned about is when the roof is in the fully open position or in the fully closed position. When it's fully open, when you think about it, it's really not that many hours where it's going to be in this position. So the relative contact for the wheels and this part of the rail system is pretty minor, and I don't think that would be a big deal. On the other hand, the roof being closed is kind of the natural state of the observatory. So one would expect that the wheels would be in contact with a fixed part of the rail system over extended periods of time. I think this is where we might want to worry about galvanic corrosion. For galvanic corrosion to occur, we also need moisture or an electrolyte. Well, the roof of the observatory is protecting it from the environment, so we're not going to have rain and moisture like that getting in. But the air itself can contain moisture. Depending on how the observatory goes, there's always the possibility of having some dew formation on the exposed metal as it cools. As I thought about this, I didn't think it was going to be a big deal. The points of contact are pretty minimal. The areas are protected from the environment, so we're not going to have a lot of water getting into things. Push come to shove, I thought I might be able to paint the part of the rails where the wheels will be resting when the roof is closed, and therefore reduce the chances of corrosion happening. So all in all, I didn't think it was a big deal, and in my own mind, I dismissed the concern. As I posted my last video, I did receive one comment that asked specifically about galvanic corrosion. Since I hadn't really addressed it in the video at all, I tried to respond in that comment to share some of my initial thoughts. And as I was doing this, another thought crossed my mind. While the wheels in contact with the rail is minimized to certain locales, and the likelihood of having moisture get in there was not that great, There is another aspect that I hadn't really thought through. I have aluminum track sitting on top of a wood top plate, and it has to be secured to the top of those walls with something. Now, it's aluminum. I could secure it with aluminum screws, but frankly, I'm not really confident that aluminum screws would be strong enough to hold the rail in place under the stresses that it would be under as the heavy roof is moving back and forth. I would probably end up using some form of steel screws. So now I have steel screws holding an aluminum track in place. And when you think about it, those screws are going to be running up and down the length of the track, and it will be also in the area in the outriggers where it's exposed to the environment. Suddenly, this seemed like a much bigger issue in my mind than just the contact area for the wheels. You're going to have a lot of screws holding things in place, and I really didn't like the idea that the two metals are joined in such a way that those areas that were securing the rails could be undergoing significant corrosion over time. I kind of hate to think that the corrosion would cause a failure that might have the roof pop off the building. Again, that would cause a really bad day. So as I thought about things more, I decided I wanted to become more conservative. I think the best thing to do is to change the rails from aluminum to galvanized or stainless steel. Now, I avoided doing this originally because of cost concerns. As I did a little bit more research, I did find a set of galvanized steel V-Trex on Amazon that would probably work fine for my application. Here's a picture of that particular product. It's galvanized, it's heavy duty, and it already has holes in it. Now, this is sold in 6-foot lengths, and it costs about $100 for each 6 foot. Then I looked at the flat track, and I had a real difficult time finding 3-inch wide flat bar stock in lengths that were galvanized that I could use. So I went to a friend of mine who is helping me with my telescope pier projects, which you'll be hearing about in the future. He has the ability to buy metals for his business, and I asked if there was any way he could find some materials that would work for the flat track. And he came back and he told me he could get galvanized steel that was 3 inches wide, and we could get it in the lengths that I needed, or he could even get stainless steel. And his cost to me for the stainless steel was $400. So I thought that was probably the best way to go. So in the end, everything that I talked about in my previous video still holds true. It's just that I've changed out what track I'm going to use. For the V track, I'm going to be using galvanized steel. And for the flat track, I'm going to be using stainless steel. And given that change, I wanted to share this update with you. Now, I'll end this video with yet another surprise when it comes to galvanic corrosion. The rails I'm going to be using are going to be mounted on the top plate of a framed wall for the observatory. Some of this wood that's building the walls and the support systems will be pressure treated as they'll be exposed to the environment, especially in the outriggers. So I'll take my stainless steel and my galvanized steel rails and I'll mount them right on top of the top plate with the pressurized wood. No problem, right? Well, not so fast. So pressure-treated lumber is used for wet environments, and the wood is preserved by infusing it with a series of chemical compounds, including copper. The copper itself goes into the wood and binds right into the cells of the wood. So I take this pressure-treated wood and I add steel rails and steel fasteners. I have copper metal in the wood, I have steel, and I have moisture. And once again, galvanic corrosion raises its ugly head. So it turns out it would not be a bad idea to have some kind of plastic liner in between the wood and the rail itself. In addition to that, you probably want to use a building code approved corrosion resistant screw or fastener. Hot dip galvanized steel is recommended and should conform to the ASTM A153 standard. If you're on the coast where you're exposed to saltwater mist, you might want to go to stainless steel. So in my observatory, I'm now going to have stainless steel and galvanized steel rails. They'll be mounted on the top plate with a plastic liner, so they're not direct contact with the pressure-treated lumber. And I'll be using hot-dip galvanized steel for the screws to fasten it. All of this to avoid galvanic corrosion. In the end, galvanic corrosion might not be a significant issue, or maybe it's an issue where over some period of time the aluminum rails could have eroded and I could have simply just replaced them. But I decided I'm spending a lot of time and money on this observatory. The critical part is the roof, and you want it to be able to roll. You want it to be able to roll well, and you want to be secure that everything's going to work and keep that roof on the building. And I decided that the difference in cost to move away from aluminum sort of made sense to me. So that's where my head is at now. And I just wanted to share that new thinking with you. So with that, I'll close this video. Thanks again for spending some time with me today. Your comments and questions are always welcomed and appreciated. Anything that helps my thought process around the design of this observatory is something I value. So if you have any thoughts, please share them. So for Cosgrove's Cosmos, this is Pat Cosgrove signing off. May you have clear skies and excellent seeing.